state the Laplace final value theorem. B, state the probability criterion of the order system. C, explain what is meant by dominant poles. Okay. So A is the answer. Alright, limit as t tends to infinity of s ft is limit as s tends to 0 s fs. Alright, if you do this, you get 2 marks. B, group always infinity criteria, what you see in the lecture notes. Alright, the system will be stable, all coefficients are bigger than 0. Okay, or alright, the inner product, A1 times A2 is greater than the outer product, A0 times A3. Okay? Alright, the inner product is greater than the outer product. That's 2 marks. C, what is the definition of dominant pole? Alright, so dominant pole by the name itself says that it dominates the response of the system, right? So dominant poles are the ones that are furthest to the right hand side. Because if something is unstable, what will happen? The whole system will become unstable. Alright, so is that a dominant pole? Yeah, yes. Alright, something is the most positive real part. Okay? Or if you have a complex conjugate pair, meaning you will introduce oscillation to your system. Yes, that could be more dominant than something that's purely real. Okay? Even if your pole that is purely real has a larger real part. Because what you're going to see on your system because of the response will be the oscillation that you get from the complex conjugate. Alright? So in short, dominant poles dominate the response of the system. But if you want to get the full 2 marks, just telling me dominant poles dominate the response of the system, I think it's either 0 or half. Alright? So what we're asking for is for you to explain to us from control theory, what does it mean in terms of the position of the poles. Okay? So you must tell us about how the position of the poles will dominate the response of the system to get the full 2 marks. Alright? B. Okay, we give you the forward half transfer function. Do you want to copy this? Can you read the handwriting here? No. The dominant pole or poles of a system are the ones furthest to the right, the root locus plot, or with the most positive real part. Okay, stop. Often, a complex conjugate pair of poles are viewed as dominant, even if a single real pole has a larger real part. Stop. Alright? The dominant poles dominate the response of the system. Okay, if there are any words that you cannot read, let me know. Alright. Shall we move on? So one thing that you might even know that you need to the right master. That's why doctors and lawyers, they don't dismiss reward work. Okay, alright. Move on. B. We tell you the transfer function for the forward half over here. But we tell you that it's a unity negative feedback system. Okay, so write down the characteristic equation and determine the range of A. Unity negative feedback says that closed transfer function is gk over 1 plus gk. This, if you simplify it, characteristic equation is a denominator, and then alright equal to 0. So from the root only stability criterion is the order, okay, related to the definition of E. So as long as all the coefficients are bigger than 0, meaning A is bigger than 0. Alright, and the inner product 8 times 16 is greater than the outer product 1 times 8. Alright, so 8 times 16 bigger than 8. Okay, means that K has to be smaller than 1 to 8. Alright, inner product greater than outer product. Okay, 8 times 16 greater than 1 times 8. Alright, combine these two conditions. If you want, you can draw a line and say that, you know, this is 0, this is 1 to 8. Bigger than 0, smaller than 1 to 8, what's the common area to satisfy both equalities? Alright? So the answer is A from 0 to 1 to 8. So this is the final answer. Alright? E, what's the steady state error? So you know the closed transfer function. Multiply that to your reference, which is 5 over S. Okay, apply the Laplace finding value theorem, so you multiply the S in front. S tends to 0. You find that it's 5k over k, which is 5. And so you have 0 steady error. Because the reference is 5, your final output is 5. Okay, so 5 minus 5 is 0, 0 steady error. Okay, Laplace final value theorem tells you what's the value of yt when t is infinite. Okay, in order to get the value of yt when t is infinite, which is the steady state output value, you apply the Laplace final value theorem in this way. This is your ys. So what I'm saying is limit of t tends to infinity of yt, which is my final value of output, is limit of s tends to 0, s dot ys. Okay? What is ys? Ys is this. Rs, 5 over s. And gs, close to gs, a over s cubed plus as squared plus b. Okay, one thing, multiply it with s. Okay, because it's to s. Alright, you enter 5. Your input reference is 5. Meaning your steady state error is 0. Okay? Anybody who thinks that I'm rubbish, you don't know what I'm doing. All clear? Okay? Alright? Let's move on. Last part. F. I give you K. So K is stable between 0 to 1 to 8. From part B. I say that K is 24. Now, they solve the characteristic equation to tell me where are the position of the dominant closed loop poles. Okay, and I'm very kind to tell you that the non-dominant pole is at S is minus 6. Okay, so tell me the position of the dominant closed loop pole. And from this position, can you tell me what's the damping factor and frequency of oscillation? Alright? So you have a characteristic equation, which is this. You had x cubed plus 8x squared plus 16x plus k. And k is 24. So you write 24 here. equals to 0. I tell you that non-dominant is at -6, so 1 pole is S plus 6. Okay? And there's a complex conjugate pair here that is supposed to identify, equals to 0. Solve this pair and tell me that dominant poles are here. Minus b plus minus square root b square minus 4ac over 2a. It's minus 1 plus minus root 3 of j. Okay? So minus 1 plus minus root 3 of j, how do you draw them on the complex plane? This is imaginary, this is real. This is minus 1, this is root 3, this is the point here. Okay, how do you tell damping factor? Alright, damping factor, according to the definition in your lecture note, is theta is cosine theta. Here. And theta is tangent inverse, the imaginary over the real, so root 3 over 1. Alright, I'll give you a calculator, we can remember basic values, 60 degrees. Alright? Okay? So cosine of 60 degrees is 0.5, which is your damping factor. So answer is damping factor is 0.5. Frequency of oscillation. Alright, for the position of the imaginary part, frequency of oscillation is 3 radians per second. So you can simplify this to 1.732 radians per second. Okay, let's take a 5 minutes break. Come back at 12:15. We'll just go through one question very quickly so that you understand a bit more about pole, location, and dominant poles. Alright? Okay, so we'll continue at 12:15.